Hello. This video is on study technique and not on any particular mathematical idea. I want to ask you to think about whether making notes by paraphrasing a textbook is useful or not. To be clear, I also did this when I was undergraduate, and here in fact are a set of my notes. I can honestly say that preparing this video is the first time since making these notes that I have looked at them again. Furthermore, given that I now understand this material better, I can see clearly that my 20-year-old self did a pretty bad job of summarizing what was in the textbooks. Okay, so if we are not writing notes by paraphrasing textbooks, videos, or websites, what should we be doing? Should we perhaps be doing what is illustrated here, namely taking someone else's notes and highlighting things from within them? I see a lot of students doing this. Maybe this is a good idea. Remember, however, that I also mark your exam papers. The students who I have observed highlighting notes like this generally do not do particularly well. So what should you do? Well, how about if you just practice what you will be doing in the exam? Think about it. If you were learning to play table tennis, you would spend your time practicing the various forehands and backhand strokes that you will use in your matches. If I were your coach, you would think I was mad if I instead insisted that you make notes about the forehand and backhand strokes that I show you. You would rightly point out that those notes were not going to help you win any matches. In preparing for a maths exam, it thus makes sense to spend time solving the sorts of problems that might come up in the exam. I would advise that whenever you encounter some new mathematical idea, the first thing you need to do is try to apply it on a problem. Applying the skill is the only way that you can understand if you can use it or not. Returning to my table tennis analogy, I could probably make a pretty decent set of notes on how to hit a backhand. If I try to hit a backhand, however, I regularly find that the ball soars off into orbit before bouncing well off the table. The time I spent making the notes would probably have been better spent hitting 200 backhands. So instead of making notes, refer back to the textbooks, the online notes, or the videos as you work through the problems, and see if you can apply the ideas that are explained in the textbook, video, or notes as you try the problem. If you get stuck, that's no problem. Just ask for help. We all get stuck with some things sometimes. This course is laid out with this philosophy of learn a new skill, practice that skill in mind. At every stage, something is explained, and there are then exercises that allow you to apply what was just explained yourself. I have done my best to explain what you have to do, but I fully expect you to struggle with some of these exercises. Please don't be shy. Ask for help if you need it. As you tackle problems, you might want to divide up your page as shown here. You can do the problem in this bit of the page. As you tackle the problem, you might look at resources in books or websites. If you reserve a space on the left of the page, you can write what resources you use to tackle the problem here. If you thus encounter a similar problem later and you find that you can't remember how you did a particular step, you can use what you've written here to refer back to the resources that you used the first time that you did the problem. Obviously, the more detail you write down in this left side column, the better. For instance, if you refer to a book, write this down the specific page number you used when you were doing the problem. The last space on the page can be used to summarize the key ideas in the problem. You should use this space to note down key formulas and equations and try to connect what you did in the problem with what you have done in other topics. Every now and again in this course, you will come across a page such as the one shown here, which just contains a collection of stuff that you need to memorize. You can even try to build up such pages yourself as you work through problems and highlight the key ideas and equations that are used to solve them. It is thus worth considering how you might go about memorizing this information. I think your philosophy should be to try to remember that there are no isolated facts in mathematics. There are connections between all the ideas, and it is as important to understand the connections between the various formulas that you are using as it is to understand or remember the individual formula. When I'm trying to learn something new, I find it very useful to represent information and the connections between ideas diagrammatically. One trick I have used to construct such diagrams involves writing each idea that I have to study on a post-it note, as I have tried to illustrate here. You can buy post-it notes in a rainbow of different colours. As you write out the facts you need to learn, you might use post-its of different colours to write facts that share some commonality. For example, you might choose to write all the definition items, like definitions of the probability mass, expectation, and the variance, on orange post-its, because all of these are definitions of things that can be calculated for any type of discrete random variable. You might then choose to write the 4 separate things about the Bernoulli random variable which you know, namely what it is, its probability mass, its expectation, and its variance, on blue post-its, as is shown here. If you have coloured pens and coloured post-its, you can use both the colour of the post-it and the colour of the ink you use to try and illustrate the categories that different ideas fall into. An even simpler way to use colour would be to use one colour for ideas that you feel you fully understand, and a second different colour for ideas that you are struggling to understand. To test if you understand a topic, ask yourself, have I solved a problem using this idea? If the answer to this question is no, then you don't understand. If the answer is yes, then you need to think about how straightforward you found the problem, whether you have applied the same idea in other different problems, if you know how to derive the results that you've written down, and so on. You understand an equation once it feels like an old friend that you have used many times. Once you've written down all the ideas you are looking at on post-its, you can then stick them on a wall or similar. On the wall, you then move these ideas around so that similar ideas appear close together. For example, if I were doing this for the information, I would put the definitions of the probability mass, the expectation, and the variance at the top of the columns like this, as the columns here indicate the definitions of the probability mass functions for the 4 random variables. This column contains the probability mass functions, this column contains the expectations, and this column, the final column, contains the variances. I would put the Bernoulli random variable at the top because the other 3 random variables here are constructed by generating multiple independent Bernoulli random variables. I might even draw arrows here in red because when I defined independence I did it in red pen. I would then write on these arrows how, by generating multiple Bernoulli random variables, I can generate binomial, geometric, and negative binomial random variables. It is also worth noting that the connections between the expectations of the Bernoulli and binomial random variables and the expectations for the geometric and negative binomial random variables. These quantities are connected because of the equation that is shown in blue, and I have thus illustrated the connections here using blue arrows. There are similar connections between the variances of the Bernoulli and binomial random variables and the variances of the geometric and negative binomial random variables because of the equation that is shown in green, so you can draw green arrows here also. What I am doing here is constructing notes. The process is active, however, in that I am using my own understanding of what I have read as I do this. I am not simply copying information from a textbook, lecture, or video, which is not that useful. Instead, I'm taking a set of facts and I'm interrogating my understanding of the topic to see how many of the connections between these ideas I understand. Notice, furthermore, that because my notes are on post-its, I can easily move them around later to reflect the refinements of my understandings that will come with further study. I can even chuck away and replace some of the post-its later on if my understanding of a topic completely changes. Notice also that this is an activity that does not have to be completed in isolation. Every stage, from writing out the post-its to arranging them on the wall, can be done with a group of colleagues. This will also likely be beneficial, as colleagues will have different ideas about how the various ideas should be arranged. Discussing and arguing for changes in the arrangement of the post-its or the colours of the inks and post-its will likely help you all to understand these connections better. Notice one final thing about post-its. They have two sides. You might therefore choose to write what the post-it is about on one side, like this, and the key related equation on the other. If you write the equation on the sticky side, it sits facing the wall. The description is on the side that you can see. An easy way to embed learning into your daily routine is to stick all your post-its above your bed. Then at the end and start of your day, just before you go to sleep or just after getting up in the morning, you can spend a few moments stood in front of your wall of post-its testing yourselves on the various things you need to know about. If you do that every morning and every evening, just think about how much revision time that adds up to. Oh, and finally, that table tennis analogy earlier wasn't an idle one. Here is a video that I think illustrates the difference between thinking you know how to do something and actually doing it perfectly.